So we have hydrostatic force, this time a different method on finding the resultant force on a plane surface, and that is through the use of geometrical method. So rather than using the equations of the previous slides, the resultant force and its location on a flat submerged plate can also be determined using a geometrical method. What does it mean? Now, if an area element dA, this one, dA, okay, of the plate is at a depth h, okay, h, where the pressure is P. And then the force on this element is dF over Pi is equal to PdA, right? However, as shown in the figure, this force geometrically represents a differential volume element dV of the pressure distribution. Now realize that this volume has units of force because it has a height P of Newton per meter squared and a base dA, which has a unit of meter squared. So dF, which is equal to PdA, is also equal to the differential volume. So what does it mean? Let us say, let us have a different illustration. So if we have this square plate submerged, so there is pressure applied over this plate, right? Pressure. Okay. And that is a uniform pressure. Okay. Then it becomes kind of a rectangular prism. So we have our width, we have our length, and we have our height. Our height corresponds to the applied pressure, which is Newton per meter squared. And our width times length corresponds to the area where that pressure is being applied. So that is M, unit of M, unit of M. So if we want to calculate the area first, that is area is equal to width times length. So what does it mean? If if your plate is uniform in its entire width, so that means for this example, rectangular prism, the same ara ang imong kabag-on, right? The same ang kabag-on nimo. What we can do is pwede na to na siya nga i-multiply our width with our L, which is our length, so that ang ato ang makita na lang is pwede 2D. Right? 2D na lang. So of course, kani siya diri becomes our area. Area has a unit of meter squared. Okay. And our height this time, which corresponds to the pressure applied, is Newton per meter squared. So that is why it says here it corresponds to the differential volume. Okay, so that is dF is equal to our value of our pressure that is in Newton per meter squared, and our differential area now is meter squared, which is from here. Then our force, resultant force, is equal to Newton. That is why it is equal to the differential volume. Okay, let me erase. Hence, mao ni siya. So, if you want to find for the resultant force, the same. Since there is many forces applied over a certain area, we do summation. And since that is over an area man, we will use our knowledge in integration and we integrate our pressure times over that area, dA. And we know that our PdA is equivalent to a differential volume. So we integrate that over that volume, and our F sub R is equal to V. Now, this is true only if our structure such as this one is regular, can be represented by regular shapes, such as if we take, for example, kaning illustration, we have a trapezoid. So what we can do is, by virtue sa itong knowledge sa statics, reduction of distributed loading, what we can do is, pwede na to ni siya i-cut here. Ayun. So we will have two kinds of loading now, right? And that is, we have a rectangular loading at the very bottom, and on top of our rectangular loading is a triangular loading. Then, provided also that our width of this color orange here is uniform over the entire length, then we can calculate for the area. And for after calculating for its area, we simply have to multiply the values here and here to get a force. That is why F sub r is equal to our V. And the magnitude of the resultant force is equal to the total volume of the pressure prism, right? And its location is, for x sub p is equal to the integral of x dv over v. Still, we just what we got the how we derive this one is just moment, resultant moment is equal to the sum of all moments. Our resultant moment, we have F sub r, and for our x component, it acts at the center of pressure is equal to the integral of our dv times x, right? So we divide both side by F sub r, divide both side by F sub r, and we know F sub r is equal to V, so this becomes x sub p is equal to the integral of x dv over V. And the same is true for our y sub p. Okay, now the line of action of the resultant force will pass through both the centroid CV of the volume of the pressure prism and the center of pressure on the plate. The important points to remember, the resultant force on a plane surface can be determined graphically by finding the volume. Although there is a bar at the very middle, what it means is just simply the volume of the pressure prism. And the line of action of the resultant forces passes through the centroid of this volume, and it intersects the surface at the center of pressure. If the submerged surface has a constant width, then the pressure prism can be viewed from the side, which what we did a while ago, and represent it as a planar distributed load W. The resultant force equals the area of this loading diagram, and it acts through the centroid of this area. So to find for the location of your what do you call this, center of pressure, you just have to do moment. Okay, so a separate exam video, for example, 4, 5, 4 and 5.